To find the margin of error, you need to use the formula E equals T sub alpha over 2 times the sample standard deviation S over the square root of n. We use T in this case because sigma is not known. The population standard deviation is not known. That's why we use T in this case instead of Z, so be mindful of that. So let's look at examples. Find the margin of error when n is 9, S is 15, and we are 99% confident. So we know what n is 9, but since we're dealing with t, we also need to know what our degrees of freedom are. And degrees of freedom are always 1 less than n, so it will be 8. S, our sample standard deviation, is going to be 15, and we still need to find our alpha over 2, which we find from our confidence. So alpha over 2 is going to be 1 minus 0.99 over 2, and that's going to give us 0.005. So our critical value for t we need to find is 0.005, and there are two ways you can go about it. You can do the table, which I'm going to show you, and I will give you the directions for how to use a calculator on that as well. So for the table, we're going to go into our t table here, and we're going to do our degrees of freedom, which is the first column here. So we're going to go down to 8. And then we're going to look for 0.005, which is always going to be in the one tail. So our alpha over 2 is going to be here. So 0.005, and we're actually going to get a t critical value of 3.355. So 3.355. That 3 is a little bit smeared, so clean it up. Now you can also use a calculator, but unfortunately the app that I use for my tablet does not come with a ability to do that, but I can kind of guide you towards it if you do have an 84, which will work. So as you can see here, under second vars is where you would go, and number 4 is where you want to go, but if you go to number 4 on mine, you see TPDF. If you have an 84, a more updated calculator than mine, you're going to have a place that says INVT, so inverse T, so INVT. That's what you're going to want to use on your calculator. So second vars, number 4, where it says INVT for inverse T. And when you're there, it's very easy. You just follow the prompts. They're going to ask for the area, in which case you're going to put 0.005, and they're going to ask for the degrees of freedom, in which case you're going to put 8, and you run it through and you're going to get a t critical value of 3.355. So that's how you use your calculator. Now, once we have everything, which we do, we're going to plug it in and get our margin of error. So our margin of error E is going to equal to 3.355 times the sample standard deviation of 15 over the square root of n, which is 9. And so our margin of error here, using our calculator to help us do the work, is going to be, all right, get out of that, 3.355 times 15 divided by the square root of 9. And just hit enter, and we're going to get 16.775. So our margin of error here is 16.775 for this information. Now how about this one? Confidence level of 95% with a sample size of 49 and a sample standard deviation of 21. Well, again, just pick out what we know. N, our sample size is 49. Our degrees of freedom, going to be 48. And we are going to need our, no, not sigma, excuse me, our S value of 21. And then our alpha over 2, which is going to be 1 minus 0.95 over 2, which will be 0.025. So our t value, our t critical value of 0.025. Again, I'm going to go to the chart. Now the chart, you're going to have to be a little bit careful. Our degrees of freedom was 48, but if you go down, you'll see that we do not have 48 here. So what you do is you go to the closest value to 48. In this case is 50. 50 is closer to 48 than 45. And then we go to our alpha over 2 value, which is 0.025, which is in the middle column. So in the middle here, we're going to get 2.009 as our t critical value. 2.009. Now, if you use your calculator, you are actually going to get a different value, just slightly different. So you would actually get t of 0.025, you would get 2.011. Not much of a difference, but enough. So I'll just put this in as calculator t value. Now it will change the answer a little bit, but not a whole lot, and both answers are technically correct. So once we have our critical value, I'll do both just to show you. Our margin of error for the first one is going to be 2.009 times 21 over the square root of 49. And our margin of error here is going to come out to be rounded to 3 decimal places. I'm going to say 6.027. That's if you use the critical value from the chart. If you happen to use the critical value from the calculator, 2.011 times 21 over the square root of 49, you're actually going to get a margin of error of 6.033. It's only off by 0.006, and they're relatively close, but they're technically the same answer. So depending on whether you use your calculator or you use the t-chart, the answers might be just off by a smidge, but there is always some wiggle room when it comes to that because not everyone has a calculator. So the work can be off by just a little bit. That is acceptable in working with these kind of questions.